Hello, space enthusiasts and curious minds alike. Today, we're diving into an astonishing discovery that's sending ripples across the cosmos. In this video, we'll explore the James Webb Telescope's latest find, a mysterious new planet, even bigger than Pluto. Stay tuned as we unravel the secrets of this celestial giant. In the vast reaches beyond Pluto, within the Kuiper Belt, lie numerous diminutive and distant celestial bodies. These distant residents of our solar system may seem insignificant, but their orbits have much to reveal. Recent research suggests the presence of a substantial gravitational force in this remote area, leading to speculation about the existence of a potential 10th planet. Our solar system, a bustling hub of activity, is home to a variety of entities such as asteroids, comets, planets, and moons, with the count of these celestial objects increasing each year. The ongoing quest to locate a ninth planet, often referred to as Planet X, has captivated astronomers, who dedicate countless hours to this pursuit. This endeavor is crucial, as the discovery of another planet would significantly enhance our understanding of the solar system's architecture. All solar system bodies orbit the Sun, governed by the universal law of gravity, which affects everything with mass. The gravitational pull on an object intensifies with its mass increase. Now, there's an exciting development. Astronomers have identified what might be a 10th planet in our solar system, surpassing Pluto in size and claiming the title of the most distant known object in our solar neighborhood. This discovery raises intriguing questions about the actuality and location of this planet. Are astronomers simply chasing a dream, or is there a genuine undiscovered giant lurking in the depths of space? Join us on a journey of discovery as we delve into the mysteries of this newfound, larger-than-Pluto entity, recently detected by the James Webb Space Telescope. The traditional solar system as we know it, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto, was a foundational part of our early astronomical education. If we also consider Ceres, every major planetary object directly orbiting the Sun within Neptune's orbit is accounted for. However, Pluto's status was reclassified as a dwarf planet over a decade ago, in part due to the discovery of another object in the far reaches of the solar system with planet-like characteristics. In the 2010 two astronomers from the California Institute of Technology brought forth evidence suggesting the existence of Planet X. They noticed unusual orbital patterns in dwarf planets and other objects beyond Neptune, known as trans-Neptunian objects. These include entities made of rock and ice, and dwarf planets such as Pluto, Sedna, Eris, and Haumea. The understanding of stellar formation has been a challenge for astronomers. Often stars are found in pairs or groups, but our Sun stands alone, lacking a twin. This peculiarity led to the belief, until the late 18th century, that our solar system comprised only 6 planets, those visible with rudimentary telescopes: Mercury, Venus, Earth, Mars, Jupiter, and Saturn. This belief prevailed until the discovery of Uranus and Neptune, expanding our knowledge of the solar system's true scope. Under optimal conditions, even to the unaided eye, the existence of a distant icy blue planet, initially mistaken for a star and then a comet, remained concealed until its discovery in 1781 by the renowned astronomer Sir William Herschel. This planet, orbiting the Sun at a distance about 18 times greater than Earth's, was later identified as Uranus. Its average distance from the Sun is approximately 1.8 billion miles, though this varies. At their closest, Uranus and the Sun are about 1.6 billion miles apart, and at their furthest, they can be around 1.98 billion miles distant. Uranus completes a full orbit around the Sun in 84 years. Neptune's discovery, which delves deeper into the mystery of Planet X, nearly occurred at the hands of Herschel. However, it was ultimately discovered on the night of September 23, 1846, by 3 astronomers. This discovery was grounded in mathematical predictions based on observed irregularities in Uranus's orbit. Neptune, too faint to be seen with the naked eye due to its vast distance from the Sun, was identified using a telescope. After its discovery, a moon orbiting Neptune was quickly found, but it took over 100 years to find a second one. Our understanding of distant Neptune expanded significantly with the Voyager 2 spacecraft's flyby in 1989. This mission led to the discovery of 5 new moons and confirmed the existence of dark rings around the planet. However, a mystery persisted. Some dwarf planets and other small, icy objects in the Kuiper belt continued to exhibit unusual orbits even after Neptune's discovery, suggesting a clustered formation. This led some scientists to speculate, based on orbital analyses, that a massive yet undiscovered planet might be lurking in the far reaches beyond Neptune, influencing these orbits. This hypothetical planet, often referred to as Planet 9, has been given various names including Nibiru and Tau, but for our discussion, we'll stick with Planet 9. If it exists, this planet would orbit in the Kuiper belt, a region receiving minimal light or energy far beyond the dwarf planet Pluto. Its orbit is expected to be highly elliptical, a common characteristic for outer solar system planets. To complete a single orbit around the Sun, Earth takes about a year, but Planet 9's orbit could take between 7,400 and 18,500 years. Pluto, discovered in 1930, has an orbital period of approximately 248 years and has yet to complete a full orbit since its discovery. Despite being reclassified as a dwarf planet, Eris, referred to here as AIS, is considered the most massive object in the distant Kuiper belt, even surpassing Pluto in mass. This makes Eris the largest known dwarf planet in our solar system. The controversy over dwarf planet status began with the suggestion that Eris might be the 10th planet. However, it is more accurately described as a distant cousin of Pluto. Located over 96 astronomical units from the Sun, Eris is currently the solar system's second most distant known object, with Earth being 1 astronomical unit from the Sun. This translates to a staggering distance of over 9 billion miles, almost 3 times further than Pluto. The discovery of Eris, despite its remote location, was likely facilitated by its significant size and brightness, distinguishing it from other planets. Eris, unlike other planets, has a highly eccentric orbit. At its closest approach, Eris comes to about 37 astronomical units from the Sun, similar to Pluto. However, at its aphelion, the furthest point in its orbit, Eris reaches a remarkable distance of 97 astronomical units from the Sun. On Eris, 1 Earth year is equivalent to 557 years based on its solar orbit. This results in extremely prolonged seasons on the dwarf planet due to the varying levels of sunlight it receives throughout its orbit. Considering the vast distance between Earth and Eris, any mission to this distant world would face significant challenges, primarily due to the lengthy transit time. An orbiter would require an impractical amount of fuel to both reach Eris and enter its orbit within a time frame shorter than a few millennia. Therefore, a flyby mission remains the only somewhat feasible option. For comparison, the New Horizons spacecraft could only perform a flyby of Pluto, and Eris is 3 times farther away. Eris is not only massive, but also has a larger land area than all of Russia, Earth's largest country. Its landmass is nearly equivalent to that of South America and greater than the entire continent of Europe combined. On Eris's surface, one would weigh more than on Pluto due to Eris being both more massive and smaller in size. The exceptional brightness of Eris relative to its size indicates a highly reflective surface, likely with a white hue. However, Eris is not the only object in its distant region of space, indicating a wealth of unexplored celestial bodies and phenomena in the far reaches of our solar system. In the vicinity of the dwarf planet Eris, astronomers have discovered a moon named Dysnomia. Unlike Pluto's larger moon Charon, Dysnomia is smaller and orbits Eris directly. Although its exact dimensions are not precisely known, dysnomia is believed to span several hundred miles in diameter. However, beyond Neptune, the solar system holds more than just planets like Pluto and Eris. In the realm of public speculation and mythology, the concept of a planet named Nibiru gained notoriety in relation to the 2012 end-of-the-world theories, which were linked to the conclusion of the Mayan calendar. This idea originated from Zecharia Sitchin's 1976 book, The 12th Planet, where he proposed a planet named Nibiru orbiting the Sun every 3,600 years, based on his interpretation of Sumerian cuneiform. Later, Nancy Leader, a self-proclaimed psychic, claimed that extraterrestrials predicted this planet would collide with Earth in 2003. When 2003 passed without incident, the prediction was shifted to coincide with the end of the Mayan long count in 2012. Comets and planets, though distinct when viewed through a telescope, often get conflated in such theories. For instance, Comet Elenin, which appeared in 2011, was mistakenly believed by some to be the mysterious icy planet X. However, the comet eventually disintegrated after passing too close to the Sun instead of colliding with Earth. Despite these speculations, the possibility of an undiscovered large planet in the outer solar system remains a topic of scientific interest. Evidence for this planet 9 has been accumulating in recent years, especially with observed unusual clustering in the orbits of objects beyond Neptune. Astronomers like Chad Trujillo, Mike Brown, Konstantin Batygin, and Scott Shepard have contributed to this research. NASA and Caltech researchers have found mathematical evidence supporting the existence of a potential planet X, a Neptune-sized object with a highly elongated orbit far beyond Pluto. Additionally, in 2020, researchers from Harvard University proposed a novel theory in the astrophysical journal Letters, which speculated on the possibility of a binary companion to our Sun and the existence of this elusive planet 9. The Oort cloud, as we understand it today, might have originated from the influence of a long-lost stellar binary companion in the Sun's birth cluster. This cluster is a group of stars that formed together with the Sun from the same dense molecular gas cloud. This intriguing theory was proposed by Dr. Avi Loeb, the Frank B. Baird, Junior Professor of Science at Harvard, and Amir Siraj, an undergraduate student at Harvard. The Oort cloud is believed to be a vast spherical shell of ice encompassing the Sun, planets, and Kuiper belt objects. It is thought to contain billions, or even trillions, of icy remnants from the solar system's formation. Long-period comets are theorized to originate from this cloud. The Oort cloud is incredibly distant from the Sun, with its outer edge possibly extending up to 100,000 astronomical units, while its inner edge lies between 2,000 and 5,000 astronomical units. For comparison, Pluto's elliptical orbit places it between 30 and 50 astronomical units from the Sun. According to this theory, a binary companion to our Sun could have played a significant role in capturing the objects that now make up the Oort cloud. Dr. Loeb explains that binary systems are more efficient at capturing objects than single stars. If the Oort cloud formed in the observed manner, it suggests that the Sun had a companion of similar mass, which was lost before the Sun exited its birth cluster. This is detailed in a press release from the Harvard Center for Astrophysics. The prevailing view is that the Oort cloud formed from the remnants of the solar system and its neighboring stars, with objects being ejected to great distances by the planets and some being exchanged among stars. However, this binary model may provide a more comprehensive explanation of how the Oort cloud came to be, suggesting a binary capture mechanism. This new model addresses a long-standing paradox. Most stars similar to the Sun are born with binary companions, a fact that earlier models struggled to reconcile when predicting the ratio of scattered disk objects to those in the outer Oort cloud. The existence of the proposed Planet 9 could also be explained by this theory. Previously, models couldn't adequately account for the potential origins of trans-Neptunian objects like the hypothetical Planet 9. but this new approach enhances the likelihood of such a planet's existence. Planet X has been intriguingly described by physicists Jacob Schultz and James Unwin as a possible ancient black hole. According to theories by scientists like Stephen Hawking, such black holes could be remnants from the Big Bang. Estimates vary, suggesting these black holes could be as large as 100,000 times the mass of the Sun, or as small as an atom. Schultz and Unwin hypothesized that this particular black hole might be about the size of a bowling ball. If this theory holds true, it could explain why telescopes have failed to detect anything in the Kuiper Belt due to gravitational and orbital anomalies. Additionally, Planet X might be a rogue planet, having drifted away from its original star system and entered ours. There have been documented instances of extrasolar objects entering our solar system, such as the cigar-shaped Oumuamua and the Borisov comet. It's believed that trillions of such outlier planets are scattered throughout the Milky Way. The popular myth about Nibiru bringing about the end of the world ties into this rogue planet theory. However, researchers from the Lunar and Planetary Laboratory and other scientific institutions continue to study and clarify these cosmic mysteries. Researchers from the University of Arizona's Lunar and Planetary Laboratory, LPL, have proposed that the Kuiper Belt, a region beyond Neptune filled with thousands of icy asteroids, comets, and dwarf planets, might be concealing an invisible object. This object could have a mass somewhere between that of Earth and Mars. In a separate and bold prediction made in January 2016, another team of astronomers suggested the existence of a Neptune-sized planet orbiting the Sun at a distance about 25 times further from the Sun than Pluto. This hypothetical planet was named, and if either of these predictions is accurate, this object could potentially become the 10th planet in our solar system. The LPL scientists believe that a so-called planetary mass object in the Kuiper Belt is influencing a group of frozen space pebbles, causing their orbits around the Sun to be skewed. The solar system, which is the average of the tilted orbital planes of most Kuiper Belt objects, GIBOs, is a key aspect of their study. They observed that the orbits of the most distant GIBOs deviate from the invariable plane by an average of about 8 degrees, suggesting the presence of a larger object that distorts its surroundings with its gravitational field. TO explained their findings. Professor Renu Malhotra of LPL's Planetary Sciences Department, a co-author of the study, likened the behavior of these kibus to spinning tops. She explained that if you have many fast spinning tops and give each a slight nudge, they will end up pointing in different directions. However, on average, they will align with the local gravitational field. This analogy helps to illustrate how these distant GIBOs might be responding to the unseen mass's gravitational influence in the outer solar system. Planet 9 is hypothesized to be located about 500 to 700 astronomical units from Earth and is estimated to have a mass around 10 times that of Earth. According to the scientific community, such a distance is too great to significantly influence the GIBOs being studied. For a more substantial impact, the influencing object would need to be within 100 astronomical units. Welcome to Blesovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blesovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe. Live Q and as sessions with experts, your membership will grant you the chance to participate in live Q and as sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blesovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.